Good morning to all. Today I'm going to discuss about microwave engineering. So microwave is nothing but it is electromagnetic waves. So based on the wavelength and based on the frequency ranges, the microwaves has been classified. So here the microwave electromagnetic waves, which includes the frequency range from starting frequency range from 300 megahertz to up to 300 gigahertz. So based on the frequency range, we are calculating the wavelength. So in general, we know that frequency f is equal to c divided by lambda. So lambda is nothing but wavelength, c is nothing but speed of light, that is velocity of light. So the c is nothing but constant value, so which c is equal to 3 into 10 to the power 8 meter per second. So based on the lambda value and based on the frequency value, my electromagnetic waves, that is microwaves, are classified. And next, so this is the frequency spectrum. So in frequency spectrum, based on the frequency ranges and then wavelength, different electromagnetic spectrum has been classified. Here, the microwaves, it lies under the range from, that is, it is less than radio waves, but it longer than the infrared rays. It covers the microwave frequency band. So for several rays, there are different frequency ranges and different wavelengths. See, according to the frequency ranges and then wavelength values, the electromagnetic spectrums are classified. So here we are covering the frequency ranges from 300 megahertz to up to 300 gigahertz. We are using for the electromagnetic spectrum analysis for the several applications like satellite communications, radar, and then point-to-point communication and wired communication, and as well as for the wireless communication, we are using microwave frequency ranges. Next, these are all the some few microwave frequency band. So here I mentioned the different frequency band names and then frequency ranges and then corresponding applications related to the frequency ranges, that is related to frequency band. So first we are starting from 1 gigahertz to up to 170 gigahertz. So based on the frequency ranges, the bands are mentioned here. So L band, the frequency range, it covers in the range from 1 to 2 gigahertz, and next is 2 to 4, and 4 to 8, 8 to 12, and 12 to 18, and 18 to 27 gigahertz, and 27 to 40. So for practical application, mostly we are using starting the frequency range from 1 gigahertz to 40 gigahertz. So, and corresponding applications we are using mainly for the satellite communications, wired communication, and wireless communications. Nothing but Wi-Fi, Bluetooth, and also in radar applications, and also for automatic radar applications, we can use the microwave type of frequency bands. Next, transmission of microwave. How we are transmitting the microwave signal, that is in transmission medium in free space. So in figure 1, I represented the general transmission media. So here the transmission media is first divided into two parts. One is guided media and then unguided media, that is wired and then wireless. So under guided media, it is classified into three types. One is twisted coaxial cable, and then fiber optic cable. Here, full and full, we are using wired communication system. And under unguided media, so unguided media, it comes under the type of wireless communication system. So in wireless communication, we are using radio wave, microwave, infrared. So these are all the main wireless communication, unguided media transmission. So next in figure 2, I represented the transmission medium of electromagnetic waves in free space transmission. So that is how we are transmitting the electromagnetic signals in the free space. So this is the second part. And next, first we are fixing. So this is the earth, that is ground station. So we are fixing the transmitting antenna and then receiving antenna in the earth station, and we are transmitting some, for example, if you consider the few gigahertz, that is 2 gigahertz to 8 gigahertz, that is C and X band. So we are transmitting the electromagnetic signal through waveguide. So because so waveguide is nothing but it is a hollow metallic tube. So mainly for the, it is designed mainly for the transmission of EM waves from source to destination, because if we are transmitting the signal from Earth to space station, we need the medium for the transmission. So this is the transmitting station, that is it is located in the base station, that is Earth, and we are transmitting the electromagnetic waves in two ways, that is one is a direct wave and then indirect wave. So direct means from Earth to that is from source to destination without any disturbance, that is without any distortion. We can transmit the signal, that is we can transmit the electromagnetic signal from source to destination, that is called as direct wave. And next another is nothing but indirect wave. So indirect wave means first we are transmitting the signal from transmitting antenna to space propagation, and next it reflect to the ground. After reflection from the ground, it reaches to the receiver part. So this is nothing but indirect wave. So we can transmit the electromagnetic signals by two ways. One is direct waves and then indirect wave. This is the transmission media for propagating the electromagnetic signal or microwave signal from Earth to base, that is Earth or base station to wave propagation. Next, waveguide. So I previously discussed about the waveguide. So waveguide is nothing but it is one of the main element of the microwave. So by using the waveguide structure, it is a small metallic structure mainly for transmitting the electromagnetic signal from source to destination, from base station to space wave propagation. We are designing the waveguide structure, and it can be divided into two or three types. One is rectangular, circular, and then elliptical part. So this is the types of waveguides. So first one, rectangular waveguide structure, circular waveguide structure, and then elliptical waveguide structure. So based on the applications and based on the frequency ranges, we can choose the different types of waveguides for propagating the electromagnetic waves from source to destination. So this is the general block diagram of entire microwave system. So first we are, so it consists of, so microwave system, it consists of transmitting side and as well as the receiving side. So in transmitting side, we are fixing the element as transmitting horn antenna. In same way at the receiver side, we are fixing receiving horn antenna. So in transmitter side, we are using only the microwave source. Here the source is nothing but power supply. So for microwave system, we are using klystron power supply. So due to the frequency ranges, we can choose the power supply. So for low frequency, in general, we are using normal power supply up to starting voltage range from 0 to 30 volt. So here we are using high frequency ranges for microwave system. So we can choose the klystron power supply as the microwave source. And second one, wave meter. So this is nothing but here we can fix the elements, some of the active and passive elements here. And next one, attenuator. So attenuator is why we are fixing the attenuator in the transmittance section means mainly for controlling the power level of the entire microwave system. Here we are connecting the attenuator type, attenuator element as the attenuator element in the transmitter section. And next one, stand. And next one, at the receiver side, we are taking the output either in slaughter line section or as well as in power meter or as well as oscilloscope or VSWR meter. So this is the main elements we are taking the output in the microwave system. And next one, finally, we are terminating the entire system. That is, we can choose the element as matched termination, that is waveguide termination. And next one, crystal mount. And here we can connect the slaughter line section for connecting the for taking the output from the oscilloscope. And next one, these are all the some few microwave components we are using for the application size. So first one, isolator. So isolator, it is a two-port device. So mainly the microwave components are designed by using only the waveguide structures. So because we are transmitting the electromagnetic signals, so we are using only the waveguide type of structures. So based on the frequency ranges and then wavelengths, we can choose the types of waveguides. In previous slides, I discussed the types. And then next, isolator, it consists of, it is a two-port device. So in first port, we are applying input signal. That is, we are applying electromagnetic signals in the port 1 and we are taking the output at the port 2. So the main function of the isolator is it is used to transmit only the electromagnetic signal in only one direction. That is the unidirection. So that's why in the isolator element itself, they are mentioning the arrow mark. So the arrow mark indicates the unidirectional power transmission. So it transmit only the power level only in one direction. So in bidirectional, at the during the reverse direction, we can't able to transmit the power in isolator component. So this is the main function of the isolator. And next one, circulator. In circulator, it consists of three port. So one, two, and backside is the third port is available. So here we can transmit the power levels in based on the port. So in first port we are applying the electromagnetic signal, and second port we are taking the output. So at that time we can terminate the third port by using the matched termination element. So we can alternatively we can take the output from port 2 and port 3. And next one, attenuators. So here the main function of the attenuator is, in previous slide itself I discussed that. So mainly for controlling the entire power level of the microwave system, we are using the attenuators. So in attenuator, it is classified into two parts. One is fixed attenuator and then second one variable attenuator. So this is nothing but, this element is nothing but fixed type of attenuator. This is variable type of attenuator. So in fixed type, we can measure only the certain particular decibels. So the attenuator, the fixed attenuator, so based on the element design, so dB level is fixed in the fixed type of attenuator. We can measure up to some few 30 decibels only we can measure in the fixed type of attenuator. But in variable type, according to our requirements, we can adjust the power levels in decibels. So here we can adjust the power levels in the variable type of attenuator. So therefore, in practical applications, we are using only the variable type of attenuator by varying the different power levels up to maximum 60 dB in variable attenuator. We can vary the power levels in the variable type of attenuator. And next one, frequency meter. So based on the frequency range, whatever we need the frequency range, here we can adjust the frequency range in frequency meter from 1 gigahertz to up to 40 gigahertz. And next one, bends. So bend is mainly used for altering the direction of the electromagnetic waves. We are using the bend type of microwave component in the various applications. And slaughter line section. So by using the slaughter line section, we can connect the probe in this dual probe in the slaughter line section, and we can take the output measurement in the oscilloscope. So this is the output device. Mainly we are taking the output at the receiver side. We are using the slaughter line section. We can connect the slaughter line section with either oscilloscope or in VSWR meter. So based on that, we can choose the output at the end of the receiver side. And next one, matched termination. So this is the main element of the microwave component. So for terminating the ports, so for example, the twist, it consists of two ports. So first port we are connecting in the input side, and second port we are going to terminate by using this element. So that is why we are using the matched termination at the every component of the microwave system. So the main function of the matched termination is, it is used to observe the entire electromagnetic signal at the receiver side. It cannot destroy it cannot destroy the any energy in the transmission line, because it absorb and store the energy level in the entire system of the microwave system. So that's why we are using the match termination for all the elements. Based on the ports, we can alternatively use the matched termination, and we can connect the matched termination at each and every element, and finally we are taking output in the CRO or in VSWR meter. And twist, so the main function of the twist is, we can alter the electromagnetic direction from source to destination. So wherever we need to alter the direction, we can use bend element and as well as the twist element. And directional coupler. So in directional coupler, we are calculating the power level of the entire microwave system. So in directional coupler, it consists of four ports. So here this is our port 1. Port 1 is always we are connecting input port. And next one, port 3 and port 4, port 2 and port 3. So the port 4 is always a terminator. So it can absorb the electromagnetic signal at the port 4, and we can take the output level at the alternatively we can take the port 2 and port 3 output level of the entire directional coupler. And next one, microwave junctions. So for calculating the different planes, that is E plane, H plane, and magic T. So the junctions are classified into three plane waves: E plane, H plane, and then magic T. So E plane and H plane, it consists of three ports. So one, this is port 1, 2, and 3. So alternatively, we can connect the match termination and we can measure the various power levels at the port 1 and port 3, sorry, port 2 and port 3. Always the first port is connected at the input level, that is at the input level, that is in the transmitter section. And in Magic T, it consists of four ports. So port 1, 2, 3 and 4. So it is nothing but in E-plane, it only the electric field only present in the direction of propagation of electromagnetic waves. And here the power levels is splitted into two ports, and finally the entire power level are in same phase. But in H plane, when we are fitting to the when we are applying power levels at the port 1, the port 2 and port 3 always it act as in out of phase. So in E plane the output level in same phase, and in H plane the output level in out of phase, that is 180-degree phase shift will be present in the H plane. And next one, Magic T. So in Magic T, it is nothing but this is the combination of both E plane and H plane is nothing but the Magic T. So the main function of microwave junctions is, so mainly for splitting or combining the entire power level of the microwave system, we can go for the microwave junctions. So under microwave junctions only, based on the requirements of the microwave system, we can choose the E plane, H plane and as well as the Magic T elements in the entire um, microwave system for calculating the different power levels. Next one, mount klystron mount with tube. So this is the main oscillator, the klystron oscillator. This part, this is we are going to connect the klystron mount at the transmitter section. So this is the main input of the microwave source. And next one, gun diode oscillator. And next one, cooling fan. So in general, microwave based on the frequency ranges, automatically the few elements, that is always the microwave elements are made up of only the waveguide structure. So due to some situations and the temperature will be due to the voltage and current relations, sometimes the temperature will be rise in the entire microwave system. So for the reduction of the, to avoid the temperature and to reduce the temperature in the microwave system, we can connect the cooling fan in the entire microwave system for avoiding the temperature. And next one, microwave components. So for transmitting the electromagnetic signals from source to destination, we can mainly we are using horn antenna for the satellite communications and then radar applications, and also for the microwave measurements in the particular structures like frequency selective surface, and for an antenna measurement we are using only the horn type of antenna in the measurements purpose. And next, parabolic antenna. Normally, we are using this type of antenna in satellite communications. And satellite communications, so in the parabolic design, we are using the radiator reflector element, and then feeding horn antenna also placed in the main part of the satellite parabolic reflector antenna. So these are all the some few antennas we are using for the microwave system for transmitting and receiving the electromagnetic signals. And this is the entire microwave test bench. So in practically, we are connecting the elements by using the microwave elements. So this is the klystron power supply. So in previous slides, I discussed some few microwave components, and this is the entire structure bench setup of the microwave system. And this is the klystron power supply, and this is the klystron mount with tube. Here we are connecting isolator, and next we are connecting variable attenuator, and next one frequency meter, and this is the waveguide stand. And waveguide stand we are connecting at both the end, that is transmitter end and as well as the receiver end. And this is nothing but slaughter line section. So in slaughter lines section, here we are connecting the dual probe. One side is connected in the slaughter line section, another end of the probe is connected to the either VSWR meter or it may be oscilloscope. So for we are applying the voltage and input in the klystron power supply, and the entire signal, the entire input is applied to the entire microwave system. And here we are adjusting the frequency ranges, and here we are this is the variable type of attenuator. Here we can modify the power levels, and finally we are taking the output at the VSWR or an oscilloscope. And these are all the few advantages of the microwave system. So the speed of the data transmission is high, and we can cover the higher bandwidth. We can carry the large amount of information, and small antennas only required. So based on the f and lambda value, we required only the small type of antennas compared to the radio waves and infrared rays, and we can utilize in the satellite communication, and we can utilized in satellite communication. And next one, disadvantages of microwave. So here the line of sight transmission is the main disadvantages of the transmission medium in microwave system. And next one, due to the rain attenuation, the signal will be lost. So here we are transmitting the electromagnetic signal from source to, that is, ground station to space station. So due to the temperature and due to the rain, we can, however, the signal losses will be there. And next one, it is equipment and maintenance can be expensive. So in general, microwave elements are more expensive, and we can transmit the electromagnetic signal up to some few large distance communication, that is based on the frequency ranges and then wavelength. Next one, applications. So in applications, we are covering communication side. We can use the satellite communication, mobile phones, Wi-Fi and Bluetooth, and then TV broadcasting. And for industrial and domestic applications, for we can using we are using microwave ovens, that is cooling fan and heating food. And for industrial applications, we can use the imaging. We can using for the heating purpose. We are using in the industrial applications, and also in medical applications. Also, we are utilizing the microwaves, that is for medical cancer treatment and radiotherapy, and also for medical imaging and diagnostics, and we are using the microwave elements. And next, navigation and defense radar. So it covers the entire radar systems, that is navigation. So these are all the some few applications of the microwave. Thank you.